In math, operations that undo each other are known as inverse operations. If we know a trig ratio and we wanted to find the angle measure, we would need to undo that trig function. In other words, we would need to use the inverse trig function to find the measure of the angle. When you're looking at a calculator, the inverse function is denoted with the -1 next to it. And we read that as the inverse sine of theta, the inverse cosine of theta, and the inverse tangent of theta. And that's what that little -1 notation represents there. On some calculators, you might also see the inverse notated using arc. So if you see arc sine of theta, arc cosine of theta, or arc tan of theta, that is also a inverse trig function representation. So basically what's happening when we want to use an inverse trig function is we'll know two side lengths of a triangle. We'll be able to set up one of our three trig ratios, either sine, cosine, or tangent, and then we will need to undo that function so that we can break theta free and solve for it. To set these up, you do the same thing we do when we know the angle measure and we look for opposite, adjacent, hypotenuse, etc. But this time they're going to mark the angle we want to find. In this case, they're using theta to represent our acute angle that we want to find. So if I'm using this angle right here, this side length of 29 is the opposite leg to that theta. And the 52 is across from the right angle, so that's my hypotenuse. So I can write a ratio using opposite over hypotenuse and create my sine ratio. But instead of saying sine of some number, we're going to put sine of what our angle was, in this case, represented by theta. So I'm going to say sine of theta is equal to the opposite divided by hypotenuse, or 29 divided by 52. Now my goal is to solve for theta, so I want to unsine this angle. So the inverse operation for that means I want to take the inverse sine of both sides. If I take the inverse sine of sine theta, I'm going to be left with just theta. And over here, I'm going to have the inverse sine of that ratio, 29 divided by 52. Now I'm going to go ahead and use my calculator. And basically what I'm going to do is I'm going to tell the calculator, I have this ratio and I want you to tell me that angle measure. So again, it's always a good idea to check to make sure your calculator is in degree mode, because again, all of our right triangle angle measures are going to be in degrees right now. Want to make sure I'm in degree mode. And now this time, to call up my inverse trig function on my graphing calculator here, I'm going to press the second and then the sign, so that way I can pull up that blue sign -1. That's right there on my screen. So I'm going to do inverse sine. I'm going to type in my ratio, 29 divided by 52, and it'll give me my angle measure. Now you're going to notice again the directions say round to the nearest tenth of a degree. So I'm going to just always make sure I look at that second value, and if this is 5 or higher, I'm going to round up. So for this angle, we're going to say 33.9. So theta is about 33.9 degrees. And that's basically all we have to do. So let's look at two more examples to make sure we understand the process. So again, we're going to look at our right triangle. We can see two side lengths labeled. There's the acute angle I'm focusing on, my theta. The side length 12 is an adjacent leg. It's attached to theta. That 19 is across from the right angle. That's my hypotenuse. When I have the adjacent and hypotenuse, that's my cosine ratio. So I'm going to say cosine theta is equal to that ratio of adjacent side 12 to the hypotenuse 19. Then I'm going to use my inverse trig function. So I'm going to uncosine theta by inverse cosining both sides. On the left, that'll relieve me with just theta. On the right, I'll have inverse cosine of that ratio. And then again, on my calculator, to get my inverse cosine, it's above my cosine key in blue. I'm going to press second cosine to open that up. I'm going to type in my ratio, 12 divided by 19. And I'll find out my answer is 50.8 in this problem right here. So theta is about 50.8 degrees. All right, Let's look at one last example. You can probably figure out what this guy is going to be. So once again, there's my theta. The 17 is the side opposite that acute angle. The 18 is the leg adjacent. So if I have opposite and adjacent, that's tangent. So we're going to say tan theta is equal to opposite divided by adjacent, 17 divided by 18. I'm going to inverse tan both sides. That'll leave me with theta is equal to the inverse tan of 17 divided by 18. I'm going to go to my calculator. Second tan, 17 divided by 18. I'm going to get 43.36, and again, I'm going to round that to 43.4 to round that to the nearest tenth. So theta is about 43.4 degrees. So that's how we use an inverse trig function to find an angle measure in a right triangle.